Let's take a look at this set of data. This is our x and our y for our function machine. We don't have any information here, so let's go to parts that have numbers in it already. So this coordinate pair here, 2 and 0. Here we have a 5 and a 3. If we put in a 2, it tells us that our output is 0. Are the numbers getting bigger or smaller? All right, so we've got an input of 5, and that's coming out as a 3. Bigger or smaller? So the rule has to have something to do with one of these, most likely. So if we put a 2, well, we have a 5 in here now. If we put a 5 into this, what do we have to do to the 5 in order to get our answer to be 3? Well, you might say subtract 2. That might be our rule. Might be subtract 2. Can we divide 5 by anything and get a 3? Any whole number? Of course, you can do fractions too. If we put in the 9 and apply our rule, 9 minus 2, our output is 7. That's what it says on our chart too. So at this point, we're pretty sure that our rule for this function is subtract 2. So let's apply that to our 0. We're going to put a 0 in and subtract 2. We will get a negative 2. Now on this one, all we know is the output. We just know a 9 came out of it. So if we take our x value and subtract 2 from it, we would get 9. In this case, we would have to solve this equation. Here's our wall. The negative 2 is on one side and the 9 is on the other. So let's get our numbers together. In order to get the negative 2 to jump over this wall, we're going to have to do the opposite function of operation, add 2 to both sides. That cancels this out. It neutralizes it, 0. Now the only thing that's left on this side is our x equals, now we're going to just solve this problem. 9 plus 2 is 11. So let's see if this works. If we take 11 as our input number and apply the rule, 11 minus 2, we would get 9. Yes, it works. So our rule for this function, subtract 2, we can put any number in. If we subtract 2, we have followed the rules of this function, and it should be on the same line when it's graphed. So let's try the graph of this. We have 0 and negative 2. Well, we need more of our coordinate plane then. We need the whole thing. If we're at 0 on our x-axis, and we're going to go to a negative 2 on our y-axis, that means down, 1, 2. So this is at 0, negative 2, right there. Then we have 2, 0, 1, 2, and stay right on that line. This is 2 and 0. 5, 3, 1, 2, 3, 4, 5, 1, 2, 3. At 5, 3, we're here. 9, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5, 6, 7. Approximately here, 9, 7. And then finally 11, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you see how these are lining up? That's a function. my dot bigger. So our function machine gives us ordered pairs by applying the rule. In this case, it was subtract 2. And we now have an orderly function that gives us a linear or a line.